Hello there, Mr. Sutton here, bringing you the IM3 Honors Chapter 6 Quiz 1 Review Solutions on simplifying rational expressions. To simplify this rational expression, since we have more than just a monomial in that denominator, we're actually going to try factoring that, see if there's any common factors, because we can't cancel anything out unless it's being multiplied by something else. So we want to turn addition into multiplication of some kind. So it looks like we've got a 21 and a 63. I can definitely factor a 21 out of all that. And also an x, because we have an x and an x squared. So if I take that out of 21x squared, that's just going to be an x plus 63x divided by 21x is going to be 3. So it looks like I can cancel out these x's outside the parentheses directly, so those completely cancel. And then 15 and 21 can also be reduced. So those can be reduced by 3. 15 divided by 3 is going to be 5, and 21 divided by 3 is going to be 7. So what's left then, up top we have a 5, downstairs we have a 7 parentheses x plus 3, and nothing else that we can cancel or reduce, so we can just leave it factored and call this done. To simplify this rational expression, I need to make sure there's no common factors between the numerator and denominator. Before I can do that, I need to know what the factors are. So factoring the numerator then, I need factors of negative 8 that add up to 2. So if we do 1 and 8, that's not going to work. 2 and 4 would work if you had negative 2 and positive 4. So x minus 2, x plus 4. In the denominator, I need factors of 28 that add up to 11. So 1 and 28 doesn't work. 2 and 14 is a bust. 4 and 7, that adds up to 11. So x plus 4 and x plus 7. Now that I've got things factored out, it looks like I have common factors of x plus 4 that I can cancel out. And I'm allowed to cancel these because if I wanted to, I could split these off into their own fraction and then just divide x plus 4 by itself to get 1. So now what's left over, we have an x minus 2 in the numerator and an x plus 7 in the denominator. To simplify by multiplying this together, it's a good idea to first factor and cancel out whatever you can, because you're going to have to do that eventually anyway, even if you multiply first. So in the upper left here, it looks like I can take a 5 out of there. That leaves me with an x minus 2. And then in the lower right, I can take out an x, leaving me with an x minus 2. And at this point, I'd like to cancel a few things. These x minus 2's can be canceled. Now, even though they're in different fractions, we can cross-cancel them because the fractions are being multiplied, which means that if I multiply straight across, these x minus 2's are just going to end up in the same fraction anyway. So I can cancel those. And then the 4 and the 22 can be cross-reduced here. Those are both divisible by 2. 22 turns into an 11. This 4 is now going to be a 2. Let's multiply across now whatever's left over. So we have a 5 times 11 in the numerator. That's a 55. And downstairs we have 2 times x, which is 2x. To divide these rational expressions, very first thing I'm going to do is turn this into multiplication. So I'm going to multiply by the reciprocal of the second fraction. Same, change, flip. Keep the first fraction the same, change division to multiplication, and flip the second one so that the x squared plus 4x plus 3 is now in the numerator and the x squared plus x is now in the denominator. Now that I've got multiplication, I'm going to go ahead and treat this like a multiplication problem. Basically, factor and cancel everything I can, and I'm allowed to cross-cancel if I want to now because I do have multiplication. So factoring pretty much everything here can be factored. Let's start in the upper left. I can take a 6 out of that expression. That leaves me with an x minus 8. And let's go to the lower left now. I need factors of 48 that add up to negative 14. So let's see, we got 1 and 48, not even close. 2 and 24 doesn't work. 3 and 16 is better, but still not quite what we need. How about 4 and 12? Well, that's getting a little bit warmer. 6 and 8. Yeah, that adds up to negative 14 if I have negative 6 and negative 8. So we have x minus 6, x minus 8. All right. Let's do this upper right now. I need factors of 3 that add up to 4. Well, only one option there, 1 and 3, which happens to add up to 4. So we have x plus 1 and x plus 3. And down in the lower right, we can take an x out of that. I always look for common factors first. That leaves me with an x plus 1. What can we cancel now? Well, it looks like these x minus 8s can get canceled, and they're in the same fraction, so there's no question. But if they were in different fractions, I could still cancel them, because again, I'm multiplying here. We also have these x plus 1s that can cancel. Anything else? Doesn't look like it. So let me multiply whatever's left over now. In the numerator, I have a 6 times x plus 3, which I'll just leave that factored. And in the denominator, I have an x and an x minus 6 that go together. Doesn't look like there's anything else I can do, so this one is simplified. To simplify this expression, since I'm adding or subtracting rational expressions, I have to first get a common denominator. Now the good news is it looks like we've already got the same denominator. So I can just keep that denominator and then just add or subtract the numerators. So upstairs, I'm going to just rewrite things now. We have a 6x plus 14. And then I'm subtracting this whole numerator. So we got to be careful. I have to distribute a negative 1 to everything up there. So we have a minus 2x and a minus minus or plus 6. Now I'm just going to combine like terms up there, and I'll rewrite my denominator. So upstairs we have 6x minus 2x, that's 4x. And 14 plus 6 gives me 20, so plus 20. When you've added or subtracted, you should always double check to see if you can factor and reduce a little bit more, because you're not going to know it until you get to this point. It looks like I can factor a 4 out of that numerator. So we have a 4 parentheses x plus 5. And we might as well factor the denominator to see if there's anything that we can cancel there. So let's see, factors of negative 15 that add up to 2. Well, 1 and 15 doesn't work. 3 and 5 does if you have negative 3 and positive 5. So x minus 3, x plus 5. And lo and behold, those x plus 5s actually do end up canceling. So then we have a 4 over x minus 3. And now this is fully simplified. To simplify by adding these expressions together, I need to get a common denominator. Before I can do that, I need to factor my denominators so that I know which factors are going into the LCD. So the first one here, I can take out a 12, leaving me with x minus 2. And then for this other denominator, it looks like I can take out an 8. That leaves me with an x minus 2 there as well. For the LCD, that's the smallest thing that both of these go into. I'm going to start with the 12 and the 8, and I'll do the other factors separately. So I'm looking for the smallest number that 12 and 8 both go into. Well, does 8 go into 12? Maybe we already have the LCD. It does not. The next multiple of 12 is 24, and 8 does go into 24. So it looks like 24 is going to be part of our LCD then. Now let's deal with the other factors. We definitely need an x minus 2 included in there. And we also, well, actually, there's nothing else. There's another x minus 2 here, but we've already covered it with the x minus 2 from the first denominator. So just kind of a quick guideline for LCDs if you're having trouble here. You're basically looking for the smallest expression that would cancel out each of the denominators. You're not trying to cancel out denominators, but if you wanted to, that's just kind of a way of thinking about it that gets you the LCD. And you only need more than one of these factors if it appears more than once in a denominator. Since the x minus 2 appears at most once in each denominator, that's why we only have x minus 2 here rather than x minus 2 squared or anything like that. Now that we've got the LCD, we're going to multiply each fraction by whatever it needs to get us this LCD in the denominator. So for my first fraction, I've already got the x minus 2, but this 12 needs to be a 24. So to get that, I'm going to multiply by 2 over 2. And I have to multiply by something over itself because I can't change the value legally of this. So I have to multiply by, I call it a fancy form of 1, a foo. Basically, just multiplying by 1 doesn't change the value. For this other fraction, I've already got the x minus 2, but this 8 needs to be a 24. So I'll multiply by 3 over 3 to make that happen. Let's actually multiply now. So 7 times 2 gives me 14 in that first numerator. Downstairs, I've got 24 x minus 2, which is what I was aiming for because we were trying to get the LCD down there. For the second fraction, 12 times 3 gives me 36 up there. And again, we have 24 x minus 2 downstairs. Since I now have the same denominator, let's keep that denominator and just add the numerators. 14 plus 36, that's going to be 50. And once you've added these, double check to see if you can reduce. 50 and 24 can be reduced. Those are both divisible by at least 2, I think. So that would give me 25 up here, and 12, 24 divided by 2 is 12 downstairs. So when the dust settles, then we have 25 in the numerator and 12 parentheses x minus 2 in the denominator. Now, it might have been possible to reduce this second fraction at the very beginning, and maybe that would have helped us out a little bit more, but hey, we're here now, and we've got our answer. To simplify this rational expression, we need a common denominator since we're adding or subtracting here. And I need to factor this lower left denominator so I can see what factors there are, and hopefully x minus 3 is one of them, but we never know. So factors of negative 27 that add up to 6. Well, not a lot of options. There's 1 and 27, which does not work, and there's 3 and 9. 3 and 9 works if you have negative 3 and positive 9, so x minus 3, which is what we were hoping for, and x plus 9. Our LCD then is going to have an x minus 3 in it, and also this x plus 9. And we only need one of these x minus 3's because it appears at most once in any of the denominators. So now let me multiply each fraction by whatever it needs to get this LCD. The first fraction is actually fine the way it is. We don't have to multiply that by anything since we've already got the LCD down there. For the second fraction, however, we've got the x minus 3, but we still need an x plus 9. So to get that, I multiply by x plus 9 over itself. And I have to do it over itself on both the numerator and denominator because I'm really just multiplying by 1, so I'm not technically changing the value, which would be illegal if I changed the value of something. All right, so our first fraction, we can leave that the way it is for now. We do have to multiply the second one out, though. So distributing my x to x plus 9 in the numerator, I've got an x squared plus 9x. And in the denominator, I now have the LCD of x minus 3, x plus 9. Since I've got the same denominator, let me just keep that, and now let me add the numerators together. So we've got an x squared, we've got a plus 9x, and then we just got a negative 36 kind of along for the ride. There's no like terms, so we can't simplify that at all at this point. However, now that we've added things together, let's see if we can factor and reduce this at all. You should always check. So factors of negative 36 that add up to 9. Well, let's see. We've got 1 and 36 doesn't work. 2 and 18 doesn't work. What's next? 3 and 12. Well, that might work if I had negative 3 and positive 12. So we've got an x minus 3 and an x plus 12. And sure enough, those x minus 3's can cancel, leaving me with an x plus 12 over x plus 9.